for the introduction, the scope of this experiment. This experiment handles boiling water at 100 degrees Celsius and water at room temperature. The mass of water is taken to calculate the energy. The specific heat capacity of water, C, is 4.187 kilojoule per kilogram degree Celsius. The time taken for temperature drop and gain is at 1 minute intervals, and this experiment is done at atmospheric pressure, which is 1 atm. The objective of this experiment, based on the manual, is to apply the first and second laws of thermodynamics in various processes.
So the theory behind the experiment is quite simple actually. It just consists of three main important things: the energy balance, the first law of thermodynamics, and the second law of thermodynamics. So the energy balance simply states that the energy in will be equal to the energy out. And the first law of thermodynamics, on the other hand, would say that the amount of energy lost by a system would be equal to the energy gained by its surrounding, considering it is a super system. Okay. And finally, the second law of thermodynamics states that the amount of entropy in an isolated system will always increase over time and will never be negative. So entropy will increase ever so slightly as time increases.
For experimental setup, we use thermometer, kettle, small beaker, gloves, large beaker, and electronic balance. Next procedure. First, we measure and record the mass of both the small and large beaker using an electronic balance. Next, fill both beaker with water until half full, then measure and record the new mass of both beakers. Boil the water inside the small beaker inside the kettle and pour back the water after it boils. And next, measure and record the initial temperature of both large and small beakers. Put the small beaker carefully inside the large beaker without mixing any of the water. And lastly, record the temperature of the water every 3 minutes until the recorded temperature of both beakers are equalized.
So for the result, so in this experiment, the first reading that we take is mass of beaker. So there will be two beaker, which is large and also small. So we take reading when the beaker is empty and also the beaker is filled with the water. So for the large one, when it's empty, the mass beaker is 255. And then when the beaker is filled with the water, the mass is 735 gram. So for the small one, the small beaker, the mass when it empty is 96 gram, while the small when the beaker filled with the water is 116 gram. And then after that, we take a reading for the temperature, which is we take a reading every 1 minute until the reading of the hot water and cold water same, 3 times. So basically, the temperature that we start the temperature for the cold water is 30 degree, while the hot water is 90 degree. And then the constant temperature for both water is 35 degree, that start at minutes 10. So basically there is the temperature versus time graph. So this is basically show that when the minute is 10, both water got the same temperature, which is 35. So that's all.
Okay. So from the results of our experiment, we can discuss about the changes in temperature against time of the hot and cold water, as well as its changes of energy against time. Okay, so we can say that The hot water changes its temperature very rapidly compared to the cold water, which we can compare by the steepness or gradient of the graph, which for the hot water is extremely steep, and for the cold water it remains relatively flat. Um, on the other hand, you can see the changes of energy in the cold hot and hot water. And as we can see, initially the there is not as much energy contained in the hot water as compared to the energy gained by the cold water. Um, what we can observe here can be explained by the fact that there is less mass overall of the hot water in comparison to the cold water, which means the cold water can absorb a lot more of energy than there is contained in the hot water. Um, and it also explains why the temperature drops so rapidly for the hot water, while the cold water barely increases in temperature. And that is all.
So for the safety precaution part, in the slide, there are 8 safety precaution that we follow during our lab session. So for the first one is use glove when handling the hot water. It's to prevent any skin burn. And then the second one is the thermometer should not touch the wall of the beaker, so the temperature that we take is accurate. And then the third one is make sure that the position of eyes are perpendicular to the scale reading of the thermometer, because we want to prevent from the parallax error. And then the next one is make sure there is no wind movement to prevent disparity in the result. Also to make sure that the result that we take is accurate, and do not spill the water as it will lead to a sleeping hazard. We don't want anyone get injured or harm in the lab. And then do not operate the electric kettle with wet hands, basically to prevent any electric shocks. And then the last one is handle the thermometer gently, because we don't want the thermometer is broke. That's all.
Lastly, for the conclusion of this experiment, from this experiment, we got to prove the first and second law of thermodynamics. The first law of thermodynamics states that the change in a system's internal energy is equal to the difference between the heat added to the system from its surroundings and work done by the system on its surroundings. The second law of thermodynamics states that heat flows from hotter region to a colder region. For the data, the energy change of this experiment is 5.4431 kilojoules that obtain a 54.17% of heat loss to the surroundings.